Unpacking sklearn's mini-batch dictionary learning, a deep dive. The mini-batch dictionary learning class in scikit-learn sklearn is a powerful tool for sparse coding. A technique used for representing data as a linear combination of a small set of atoms or dictionary elements. This is particularly useful when dealing with high-dimensional data where traditional methods might struggle. Here's a comprehensive breakdown of mini-batch dictionary learning. 1. Core concepts. Sparse coding. The goal of sparse coding is to represent data points as linear combinations of a few dictionary atoms. This is achieved by finding a sparse representation of each data point, meaning that only a small number of dictionary atoms have non-zero coefficients. Dictionary learning. The core of the algorithm is learning a dictionary, which is a set of atoms that effectively represent the data. This dictionary is not fixed beforehand but is learned during the training process. 2. Algorithm. Mini-batch dictionary learning employs an iterative algorithm that alternates between two steps. Sparse coding. Given a dictionary, the algorithm finds sparse representations of the data points. This is often done using techniques like the lasso least absolute shrinkage and selection operator, or orthogonal matching pursuit (OMP). Dictionary update. Using the sparse codes obtained in the previous step, the dictionary is updated to better represent the data. This is achieved by minimizing a cost function, typically a combination of the reconstruction error and a sparsity penalty. 3. Mini-batch learning. The mini-batch part of the name indicates that the algorithm operates on small batches of data, instead of processing the entire dataset at once. This is particularly beneficial when dealing with large datasets, as it can significantly reduce the computational cost. 4. Key parameters. N components. This parameter defines the number of atoms in the learned dictionary. A smaller number of atoms leads to a more compact representation, but may reduce the accuracy. Alpha. This controls the sparsity of the codes. Higher alpha values lead to sparser codes. Niter. The number of iterations to run the algorithm for. Batch size. The number of data points in each mini-batch. 5. Applications. Feature extraction. Sparse coding can be used to extract meaningful features from high-dimensional data, leading to more efficient and accurate machine learning models. Image compression. By finding a sparse representation of an image, you can achieve significant compression without losing too much detail. Signal denoising. Sparse coding can be used to remove noise from signals by exploiting the sparsity of the underlying signal. Anomaly detection. Unusual data points often have sparse representations under a learned dictionary, making sparse coding useful for anomaly detection. 6. Advantages. Handles high-dimensional data. It can effectively represent data with a large number of features. Data-driven. The dictionary is learned from the data, making it adaptive to the specific characteristics of the data. Computational efficiency. Mini-batch learning significantly reduces computation time for large data sets. 7. Limitations. Choice of parameters. The choice of parameters, e.g., n components, alpha, can significantly impact the performance. Finding optimal parameters may require experimentation. Interpretability. While sparse coding can effectively represent data, interpreting the learned dictionary and the sparse codes can be challenging. 8. Example. Python. From sklearn, datasets. Import low digits. From sklearn, decomposition. Import mini-batch dictionary learning. From sklearn, feature extraction. Import image. Load the digits dataset. Digits. Low digits. Flatten the images for processing. X digits. Data. Train a dictionary learner. MDL mini-batch dictionary learning. N components 100. Alpha 1. Batch size 100. MDL. Physics. Transform the data using the learned dictionary. Code MDL. Transformx. Reconstruct the original data from the code. Reconstructed data MDL. Inverse transform code. Visualize the learned dictionary. Components MDL. Components. Image. IM show components 100. Reshape 10. 10. -1. In summary, mini-batch dictionary learning is a powerful tool for sparse coding, particularly suited for handling large, high-dimensional datasets. Understanding its core concepts and key parameters allows you to leverage this technique for various applications like feature extraction, image compression, and signal denoising.